So in this video we will examine the relativistic effect, that is mass increase, time dilation, and space contraction. As earlier, you should have a look at the previous videos to understand what this video is all about. Otherwise you will not understand. Okay, so first we will start with the relation between mass and velocity. And to do this, we will start with examining the delay of the shells around an electron in movement. We always use the electron since this is the most simple particle. It has every characteristic that we need to look at. We will later on extrapolate to any particle, etc. Okay, so if you look to this deformed shells, we have already seen it when we were looking at the magnetism. So you get that the radius or the distance between the electron and to one of these shells are deformed due to the speed. You have R0, which is the radius without any velocity relative to the free Daons. And here you can see that you get a certain equation, which we have seen already before. Now, we will now go a step further and we will have a look at the interaction in the opposite direction. That is to say that the electron influence the shells, so they stay in a certain position, but all shells are also influencing the electron, so that the electron is in equilibrium. So if you do this, then you have to add something in the opposite direction. So in the equation you just add a pi to the theta, and you get the opposite situation as you see in this figure here. And then you can multiply these two functions together and take the square root of it, and you obtain that you have a reduction of the size of the shells according to the formula you see here. You can make the square root, that is geometrical interaction, geometrical reduction, because the Daons between themselves, if you have Daons with different size, then you have to multiply them together and take the square root of it. This is a geometrical mean that you can see here, and these are leading to that also the path of the signal to and fro, which is different in dimension, has to have the same thing. It's a geometrical mean of the path, and that is what you have seen in this earlier equation. So this leads to a reduction of size of the shells, but since the free Daons surrounding the electron in movement is always the same and gives always the same disorder, then if the shells of the electron are reducing in size, then you have to add the shells to reach the size of the free Daons surrounding. And this leads to an increase of the number of shells and therefore the mass of the electron. So since this is a reduction of the electrons' Daons, this is exactly the same thing as if we increase the dimension of the free Daons surrounding the electron. And this we can do with the help of the program we already talked about, the EP, which is an equilibrium around an electron, radial equilibrium. And we reuse this program and we take that the mass is constant of the Daon, and we vary the size of the free Daons in a wide range, and we obtain a result like this, that the mass is equal to the rest mass, let's say, multiplied by the gamma. This is straight out the formula of Einstein. In fact, it's not Einstein, but Henri Poincaré. Okay, so this is gamma comes out immediately. You have no problem. So what is interesting here also is that you see that the electron has its minimum mass when it's perfectly spherical, which means that if you have some interaction acting on the electron, then the mass will go up. I mean, any field or whatever that comes in contact with the electron will increase the mass of the electron. So this is also an important point. Okay, now, so this is the mass increase. As you see, it's quite straightforward. And we take a look at the time dilation. So why is the time changing? Well, this is very simple also. I mean, you have that if the mass is increasing, then of course the acceleration and the speed between various particles within a lump of matter go with high speed. So all participants in particles should have the same speed. Then you have that the speed or velocity of interaction is reduced, opposite to the mass. I mean, inversion of the mass. The mass increasing, the time is reducing. So this gives immediately the time dilation formula. It's just that the mass is growing, so the time becomes longer to exercise the same given thing. So it's a general reduction of activity, let's say, within something that goes at the same speed, close to the light speed, let's say. So left over becomes then the length contraction. The length contraction, we have to look at the of the different angles between the if you look to one specific shell, you have that the Daon's rotational axis is not pointing to the electron but slightly behind it, and this gives an angle so that from the outside you have that this or from the electron or from the shells you have that this is not exactly in equilibrium, so you have to increase the radius of the transverse sense. You have, if you look to this angle, this is a maximum at the perpendicular to the electrons relative to velocity. So you have a deformation of the shells. To compensate for this, you have to increase the radius to compensate for the reduction of the radial equilibrium due to the angle. And this increases the radius in the transverse sense. So you have that is in the sense of velocity, you have that this electron is flat. The shells are contracting in the direction of velocity, and it's increasing. No, it doesn't do. In fact, it's the transverse dimension stays the same, but you have the contraction of the longitudinal direction. You can express this in a nice formula like this here, and you have the image here showing you more or less what's happened. So although you deform the shells around the electron, you have that radial equilibrium must always be in place. I mean, it always has to be an equilibrium, since free down surrounding always have the same interaction. Then you don't have any variation of the force equilibrium, even if the shells are deformed. So the formula for mass increase is the same as before. There is no changes, and this is also quite simple. You should notice that since external free downs are always the same size, the same interaction, etc., you have no change of the charge or the electric field or the potential surrounding the electron. At a certain distance away, they are always the same, constant. So the changes you have, relativistic changes you have, is always close to the electron. And this is, for instance, the mass is growing, but it's growing inside the electron. You should notice that the charge of the electron remains constant. That is to say, you don't have a variation due to the speed. This is due to the fact that the free downs surrounding the electrons are always the same value, same size, so that the radial equilibrium a bit out from the electron stays constant. That's why you see in the Maxwell equations, for instance, you have no dependence of, you have no relativistic influence from this besides the mass increase. So this is important to understand.